Hi, Dean Myers from VisWorld here, bringing you news from Washington, D.C., where I'm attending the Data Innovation Day conference founded and hosted by the Center for Data Innovation. In this segment, you'll hear about both the importance of open data and practical uses for that data, particularly in how it's used to create visualizations of information that give data meaning and context. You'll hear first from Joel Gurin, author of the book Open Data Now, Senior Advisor at the Governance Lab at NYU, and Director of OpenData500.com. Next, you'll hear from Matt Baily, a brigade captain in Washington, D.C. for Code for America, who will be showing us a demonstration of a data visualization. And next, finally, a brief overview of CartoDB, an open source mapping platform. Please join me.
I'm at the Data Innovation Day for the Center for Data Innovation, and Joe was speaking on a panel about open data, but I also want to ask him about, he started to mention about there's a whole class of companies and businesses that are managing data, and I thought I would ask him if he would go a little more deeply into that, and particularly those who might be focusing on visualization of data as a business proposition.
Sure. We're actually just beginning to see companies that are really focused on data visualization as a real significant driver of business. I think we're going to see a lot more in the next year. What we are seeing right now is companies that are doing a lot of work to make government data just more usable and more accessible. I'll give you a few examples. So Enigma.io, which actually won the TechCrunch Disrupt contest in New York about several months ago. They're taking federal data sets and basically just kind of using brute force to put them on common platforms, make them all interoperable, make them all usable, and they're making a lot of progress very quickly. A company called OpenGov, which is working with city data, initially in Palo Alto and some cities in California and now nationwide. They actually have some very basic but cool visualizations that make it very easy to take something that otherwise would look like an obscure kind of financial spreadsheet and turn it into data that you could use at a town hall meeting that anybody could look at. Companies like Socrata, which have set up platforms for both federal and state and city data all over the world, and many others. So I think what we're seeing is that people are not waiting for government data sets to be open and accessible on their own. They're really accelerating that process with some of this very, very good work on data analysis and data presentation.
What about, are you getting, do you see hybrid companies, for instance, Google partially sharing part of what they're doing with government data, or vice versa, or being able to work quote-unquote Google Analytics, which is in theory private data, with open data?
With open data. Well, we're seeing an awful lot of companies that are bringing in open data and using it together with their own data to draw some conclusions and or just for strategic purposes. I mean, I'll just tell you one example I heard of the other day is apparently a lot of the moving companies, moving vans, are now using all kinds of demographic and other data to figure out what moving patterns are likely to be and where they should concentrate their business. So they obviously have a lot of their own business intelligence, and now they're adding government data to that. Some of the real estate companies, I think in a similar kind of way, real estate websites, a lot of examples of public and private data sources coming together for business purposes.
Well, thanks for the time, and thanks for the information.
Very welcome. Thanks.
Code for DC is the DC Code for America Brigade. We're an all-volunteer meetup of civic hackers, data scientists, data visualization folks, user experience people, journalists, and just activists. And what we do is we meet at least every couple of weeks, and we have hackathons to work on projects that help address social and political problems in the city, ranging from making social services work better to helping parents make decisions about what school they want to send their kids to driving civic engagement with the political process through the lens of technology, through the lens of data, using a variety of different techniques and tools. So what you see on the screen here is, it's actually 3 browser windows. Up top is just the masthead on our main website. But on the left here is a project called Open Schools. This is very much still in progress, but is actually live on the internet right now at edu.codefordc.org. So what this is we've sourced a bunch of data directly from the school district. They provided us with statistically equivalent but anonymized data about where students live in the district versus where they go to school. So what we're doing is we're taking this information along with other data sets that we're sourcing both from the government and also from community groups and elsewhere to try to build a tool that will help parents quickly and concisely decide where they should be targeting for their students to go to school through the lottery process, make basic decisions like do they want to keep their kid in public school or send them to a charter, and just generally make that conversation easier and smarter for parents who don't have the time to burrow into the data themselves, maybe working multiple jobs or may not even have a good framework for thinking about what are the different qualities of a school that I should be considering beyond the basic ones like safety, reputation, and where other kids from the community are going to. So the particular screen that we have pulled up right here is actually just a basic data visualization that shows where students live, that would be like that epicenter right there, versus where they go to school. So higher intensity lines in red or in orange indicate more students, and the yellower lines would indicate fewer students. And so it shows certain basic truths, which are that kids who live in Southeast Washington tend to travel greater distances to get to school than kids who live in Northwest, Northeast. That's not that surprising, but what that means, like packaging it up in this way, allows a parent to understand, basic truths about like if a kid has a lot of other students who live in their neighborhood who they know and interact with. Some of those students are clustered going to the nearest high school. Is that true for basically everybody in that neighborhood, or should the parent be evaluating travel time against the fact that a lot of parents like them are choosing to make other decisions? So it's not a very sophisticated tool at present, but what we're doing now is we're building out our second generation tool, which first of all is going to be a mobile first design, meaning it'll put this type of tool directly in parents' hands. And then we're also building in many other vectors that parents might want to consider into sort of a wizard format that will include many different styles of visualization and allow parents to quickly drill down and come to basic decisions about what schools they may want to target for their student to attend.
So this is a volunteer effort that you're putting together?
Yeah, so this is all volunteer. I'm playing hooky from my day job at the Consumer Financial Protection Bureau right now. We started about a year ago. We do receive some funding and logistical support through Code for America, as well as through other partners like the Sunlight Foundation and the Open Gov Hub, which is a shared workspace here in DC.
How do you decide who gets on what team to do what aspect of things? Where do you get the visualization scientist and the right programmer?
Yeah, it's essentially self-selected. So, at the beginning of every meetup, I give a spiel that says, if you came today, you have a pet project and you want to turn it into a Code for DC project, the way you do that is right now you raise your hand and declare it to be a Code for DC project, and poof, it's been instantiated. And so what we do is we encourage people who are running a project or who are the representative for a project that's already underway to just identify resource needs that they have. And that could range from we need somebody to write copy for us, to we need usability testers, to we've got one data viz person, he or she really needs help, and please step forward. Or if you know D3, please step forward. So in this case, this group was really lucky to start off with a good mix of subject matter experts from government and really sophisticated data scientists.
Do you also get donations of software or other kinds of things you would normally have to pay for?
We largely use open source technology or just build it from scratch. So we take great pride in posting all of our code up on GitHub. Some of that's under our organization, which you can find really easily, and some of that's spread across our members' accounts. That's largely what we do. So we've placed a much greater focus on using web-based technologies rather than proprietary desktop solutions for doing mapping. We place a great emphasis on using libraries like D3 tools like Mapbox to create visualizations that we can easily publish and syndicate across a variety of platforms.
Thanks for your time.
Yeah, wonderful, thank you.
So I'm here at Data Innovation Day to show off our tool CartoDB, which helps people make maps easier on the web. It's a tool that sort of encapsulates a lot of the hard, difficult things about putting data on the web with maps. It lets you take large data sets, display them on base maps, wire in things like mouse clicks and legends, and add design and filters to that data very easily. We like to say at CartoDB that we have a long and gradual learning curve. You can jump in and start making maps in minutes, but then you can also learn some of the more advanced skills to really customize your maps and make them exactly how you want them. If you take a look here, this is sort of the basic interface for uploading a data set. This is a data set, a CSV that I uploaded of 50 years of tornadoes. And then using the wizards available in CartoDB, I just customized this visualization and animated it over time. Some things that you can customize on your own are things like the base map. You can select some CartoDB base maps, some Mapbox base maps, or Google Maps even if you like. The wizards allow you to change visualizations, not just animated visualizations, but things like intensity maps or choropleths. And then you can really get into the CSS and change the things about your style exactly like you want them, things like the color, the size of the markers, how things are displayed. And then sort of one of the most advanced things you can do in the interface is really get involved with writing SQL. And that lets you modify data, change the way that it's coming to the map, both with filters or geospatial queries, so querying how close different features are to each other. And then finally, you can publish these maps in your web pages or share them as URLs through Twitter or an email. And then we have a JavaScript library, so you can also build these right into your website and wire in things like click events and filters and dynamic queries directly to your data. And CartoDB really is about that dynamicness of your data. So this is the data set, and you can filter it and visualize it a million times differently. So
What's about the largest size set that you said that you could handle comfortably before it just becomes too cumbersome?
Well, I've seen, it's an interesting question because CartoDB is really built on a relational database. So you have many, many tables, and you can do a lot of things with CartoDB and the ability to run SQL right in your account, which means you can do joins and subsets on the fly. And because it's dynamic, it can handle that. And so the size of your data is really a difficult question. If you're asking about a single table that I've seen a lot of tables that are in the millions, and tens of millions even, and display on the map really quickly still. The more that you want to start doing dynamic things, the more you want to be careful about that. I've put the entire database of US zip codes at the highest resolution. It's somewhere close to 2 gigabytes in a single table, and it displays fine. You can run dynamic queries, dynamic styles on that data set. But then you could run optimizations on it and make it display even better and faster. And so because it's a relational database, when you start getting to those advanced questions of really large data sets, we work with you, and our customer support really works to make that fast for you.
What would you say is the typical kind of user?
Yes.
It's also probably a hard question.
Well, no, I think it's difficult to pinpoint one, but I think it breaks down into a couple different areas. We have a lot of developers that don't want to run their own infrastructure for their clients or tell their clients how to run their own infrastructure. And so CartoDB lets them put data online and make maps that work behind the scenes. And also, because APIs are available for you to access that data as JSON, GeoJSON, CSVs, KML, it lets them build that into websites without having to run their own infrastructure for their clients. We also have journalists, people that are writing online news articles and stories are using CartoDB quite a lot, especially for the dynamic data capability. So running election maps on CartoDB has been a common thing lately, where you design the map once, and throughout the night as new election data comes in, those maps update, and we take care of all the caching and making that fast for you. The other big area of people using it are large businesses that use their own data on CartoDB, and a lot of times are making maps to look at them internally and share the maps with just either their close clients or with their coworkers about how their own business analytics are working. So we're starting to see a lot of that too. Primarily, it's run on the cloud. We are pretty flexible about our cloud offerings, so we can run in the government cloud, for example. And we also have an on-premise offering that we work with some of our bigger clients if they, like you say, are behind firewalls and they need really particular uses of the platform. And then we just handle those on a case-by-case basis. People contact us and we work with them to make it happen.
I appreciate the demo.
Cool.
And thanks
Yeah.
for your time.
Yeah, thanks very much for stopping by.